Hello everyone, welcome to week 3 materials for MK304, and the purpose of this video is to provide a brief orientation and introduction to a few of the labs associated with this week. In particular, on the screen you can see here the week 3 virtual lab, which is focusing on some of the general US demographics, and then we will have the week 3 application activity to look at customer lifestyle segmentation. So a couple of these activities that we'll be working through in terms of the virtual lab and the application activity will be fairly well scripted. There will not be any type of specialized software or anything like that that you'll need. All that we'll need to do is step you through some of the basics here and explain a little bit further on what we'll do for both of them. So I'll start off here with the week 3 virtual lab and try to keep it short and concise to best help you. Just about every week we'll have a virtual lab, and the purpose of these virtual labs are designed to give us a springboard into the application activity. So while they are not graded or anything like that, they are really important to give you the background necessary to go into the application activity. So to begin, let's go ahead and click the USA demographics link right here. And once that comes up, what I recommend doing is reviewing this. So either you can pause and review it on your own, or just listen to me and we'll step through it in brief fashion here. But we're going to conduct a small census demographic investigation of some differences in population. Some of this we went through very, very brief in week 1 with kind of some general CAN data. And so at this point, there'll be nothing that you will need for specialized software, but what we're going to do is go through this demographics virtual lab document right here, and there'll be some questions in this document that you'll see with the little question mark, and those will be provided to you. With these question marks, they'll be providing answers to you to best help you along. So once we open up this link, the next step will be to click on the URL that is contained within this PDF here. So let's go ahead and open up this demographic PDF layer here, or PDF document. And so we'll be looking for generalized patterns in US population data. And the virtual lab is very short, actually. It's just only two pages here. And so we'll be looking at population variability within our data sets. Where are those areas varying? And then we'll also be looking at income as well in this virtual lab, and then age. So then we'll be looking at scale of our data as well. And so scale is really important. Perhaps in some other weeks you'll be looking at different aspects of scale, but scale can make a difference in how we are referencing or determining or making inferences from our spatial data, from our GIS data. For example, let's say we zoom in other words, get really, really close to your hometown or something like that. We can see all the individual houses that we could represent as little points. You know, one of the three big takeaways from GIS is that every feature will have, in reality, be represented as either a point, like a town or a home, maybe a house, a line such as a road or a sidewalk or utility lines, or a polygon, which is an area that could be your lot, you know, with your home. If you do own a home, it could be a boundary of a market area or your sales districts or something like that. So points, lines, and polygons. So scale, if we zoom in really, really closely to your hometown, you can see little dots maybe that could be homes on imagery. But now if we zoom out a long ways, no longer will that city be comprised of hundreds of little dots. Instead, the city, such as Minneapolis, may be represented just by one dot, 1 point. So scale is really an important determining factor for how we influence, or rather how we interpret our data. So that's the last part of this activity, is to get you familiar with that in the virtual lab. So the next step, as we're following along here, is to click on either this link here and then follow the guidelines and work through the lab. So let's go ahead and do that. And I'll just show you what this is like, so that it will give you a sense of what the interface should look like as we're going through this. And so in this case, we're looking here at, generally speaking, the population density. And what I'm going to do is leave my screen up here, and if you have your screen up at home, you'll be referring to this document right here. So we just launched the map, and right now it's to follow these little question marks and think about, based on the map that we have in front of us here, which part of the United States is most heavily populated. Well, looking at our legend over here, this legend describes the number of people per square mile, which is consistent with a density. So the number of given units per given area. And here shouldn't really be too much of a surprise, but the East Coast. And so if we zoom in on this, which is part of the next part of this activity here, if we continue to zoom in using our tools up here, I'm going to just left click here and just hold down and drag over to the east over here around New York. Now what's happening as we're zooming in, we're starting to see our scale, our units change. So just as before we were talking about polygons, all of these individual, looks like they might be census tracts. I'm not sure. We'll see if we can click on them. I don't know if they have data associated with them here, but looks like these are census tracts here. So as we zoom in closer, we'll be able to see census tracts, or we don't really have any point data here. But this is an example of a scale that we were talking about. All right, so feel free to explore all of this and any of it, and work through the rest of this here. And I don't know, folks will have to let me know. I'm more than happy to demo all of these out. Sometimes people think that it's a little bit waste of time because they can do it on their own much more quickly, but I'm also happy to provide that information too without trying to make it too long. So I guess you folks will have to let me know and what your preferences are. If you would like for me to step through this with you individually on a one-on-one basis, I'm more than happy to do that. So we'll see if I can just cover some of the highlights here of the remaining aspects, because this shouldn't really take us too long to go through here. So we looked at some of the population density, and let's go ahead and now look at the income. And so our income, I'm going to come back over here to the content. So we're under the legend. Let's make sure that we click our content. Now we're going to take a look here. I'm just going to make sure I have my guidelines set up here. But we wanted to click on a median household income in major cities. So I'm going to turn on my major cities. These are all great examples of points now. Point GIS data and median household income. So all the other layers should be turned off, which they are. So now we're seeing some cool information that's associated with cities and then household income. So if we come back over to our legend right here, let's click our legend. And here we have some ordinal symbology right here. So ordinal data means really not that important for the class here, but ranked data. So in statistics, if you see ranked data or ordinal data, that means that it's ranked data. So the bigger the circle, the bigger the population. So obviously here in New York, we could see that. But if we go around the US, see some of the bigger cities, on the West Coast, down south a little bit there, and of course in and around Minneapolis. But the interesting thing here too is when we're looking at the median household incomes, we can see that the greener the areas are, the higher the household income. And it looks like these might be in counties now. So each one of these counties is a polygon that we're looking at. So as we zoom in or out, again, we can kind of see how all those change as we get into different scales. Maybe they don't have that available here with that particular data. We had in and around the metro, the areas in green have the higher household income. And one of the things that our guide asks us to explore are how are the median household incomes in cities related? And the solution that we've explored here is that the household incomes tend to be higher in and around adjacent areas. So the further we get from some of the bigger cities, the incomes are tapering off a little bit as we get to at least in northern Minnesota, southwestern Minnesota, or northeastern Wisconsin. Let's move on to analyzing some of the age differences here. So I'm going to come back over to the content button and I'm going to turn on the layer median age. I'm going to turn off everything else. Turn off household income and the major US cities. And then we're going to look at the bookmark here of our states. And I'll get that pulled up here and then be right back with you. Okay, and so the next step was to select up here on the top the bookmark, and we're going to go to state. And what this does is basically creates a unified scale that's predetermined for us that we can use. So according to the next question, which state has the highest median age? And looking at, if we open up our legend here too, so again, the darker the blue, the higher the median age, and looking at this would be Maine and some of the upper Northeast states. Let's see here. The youngest populations, which would be another question down on our virtual lab there, would be, looks like Texas, Utah, perhaps there, yeah, maybe Idaho, they're saying, but here we can definitely see the two states here, Texas, California, perhaps there. And now let's go up to the bookmarks for county. All right, so if that activates for you, now it said, how did the pattern change? And so the patterns that we're seeing is because we zoomed in closer, our scale changed. So that enriched our data a little bit more. So in other words, we have more refined data, and that's how there's more data access here. So the higher the blue, once again there, the higher the median age. And now it says that we can go back into our content button here and turn on the layer median age for Utah and Florida census tracts. So census tracts, we can think of those as being more alike than compared to zip codes, for example. And census block groups being even more homogeneous than census tracts. So it's really a scalable thing here. Now it said zoom to Florida. So I'm going to go ahead and zoom out here. And let's go ahead and zoom down here to Florida. Maybe there's a bookmark here too. Florida tracts. Let's go ahead and use our bookmark for that. And are all the elderly, or well, I'm sorry, are all residents of Florida elderly? You know, so if we go back to our legend, we can explore the median age. And no, definitely not. The answer is, are all the residents of Florida elderly? You know, no, according to our data, median age and whatnot here. So kind of fun just to explore this data. And the best, or the frustrating thing about data that we have is that it's a snapshot in time. So we talk about big data in other classes, or as we get further down in this course, having real-time data almost is making our decision making a lot more responsive and a lot more relevant. So as an analyst, that's what happens when we're dealing with older data. It's just a snapshot in time at that moment. But we're just trying to learn some of the principles here. So let's go on to the last part of your virtual lab, which is the scale of influence and the interpretation of data. So I'm just going to pause here and get my notes out here, and then we'll step through that very briefly. Okay, so moving on to the scale of influence, let's go up here to our bookmarks. And this is consistent with the directions on our PDF. We're going to select the bookmarks and then select Utah tracts. And this should zoom us in, if you will, to areas in and around Utah, in this particular area of Salt Lake City. So at this scale, which bordering state shows the sharpest contrast? here. And here we can see Colorado, still in Utah here, Nevada. So when they're looking at, just going to come over here, I think we're still in median age, which we are. So looking at the median age, where is there a lot of difference here with the adjoining other states? And Colorado does have some of the sharper contrast, although arguably this area in Nevada does too. But it's fun looking at the differences really, and where are maybe older populations in states or in counties. So it's pretty interesting to see there. So what's surprising about Idaho? That Idaho is a low median age state, but many higher median age areas are evident at the county level. So, practice by zooming in and out on here and seeing what's happening in and around areas that are darker the blue, the higher the median age, so 55 to 66 in this case. All right, then the last step here is to take a look at the bookmarks tab again, and we're going to go in here to Oklahoma City. And let's look at Oklahoma City next. Okay. All right. Okay, so we left off there with our bookmarks to Oklahoma City. And when we first click on our bookmark here, the next or the last question says, what age patterns do you observe? And really, we don't see any age pattern here. And I think this might be a fault of the pre-canned exercise here. But let's go ahead and click this zoom out button. Right now we can't see median age, maybe because they don't have any data associated with it at that level. So let's just go ahead and zoom out a little bit, 1 or 2 times, that's fine. And here the question is, what do we observe in patterns? And if we look at our legend up here, make sure your legend is active, we can see that it's fairly light blue, maybe in the 35 to 40-ish area in and around here, but kind of in the east or northeast area in and around Oklahoma City here itself, that there is a younger median age in this area. So that's maybe a trend or a pattern that we're seeing here in our demographic data. So explore this further as you wish. And again, let me know if stepping through all these activities are helpful or not. That would be helpful for me to know what other value you could take out of this. So we'll come back in just a moment and outline the application activity and step you through the principles of that. Okay, everyone, welcome back. And we'll be stepping you through some of the setup protocol for the application activity for making product determination. So we're trying to ease you into how do we integrate data into business analytic decision-making processes and or business marketing, things of that nature. So we're going to continue the use of profiles and tapestry segmentation to help us identify strategies to make a product determination. So this one I think is kind of a fun one here. This will be for a furniture store and retail in the Chicago area. So let's go ahead and take a look at that. And this one might take you about an hour. So again, you have to let me know. I'm happy to go through all of these things step by step with you. Comments that I sometimes hear, it's too long. I'm happy to do this better on my own, or there's too many videos if they're broken up. So you'll just have to let me know what works best for you all. So let's go ahead and carefully go through our application activity. And as that's getting set up, I'm also going to come back here and open up the application activity itself. And there should be 4 questions. I'd like to step us through this first. So okay, 1 second here. Okay, so the week 3 application activity, this will be the document that you will need for this that we have opened right here. And no login credentials or specialized software are required. So we'll step through these and then we'll briefly go through the outline. So there's a case study associated with this that I mentioned, and there's a small set of steps inside of that scenario, little tutorials I call it, steps 1 through 17 to help you through this tutorial. And then on pages 8 and 9 of this document, let's go ahead and we'll open that up. Pages 8 and 9, there'll be 4 questions, and these are relatively simple, and they're summarized below down here as well. So it'll be four general questions. Again, pretty basic stuff here, but that's okay. And so as you work through the tutorial, you'll be answering these questions along the way. And so for the product is simply to provide a brief response in a Word document and then upload that to Blackboard. And that would be right here. So where we'd enter that. And so then what I can do is look at those, provide you any feedback, and get those back to you to correct if you wish to do so. So the process is to open up our tapestry segmentation exercise, follow the steps associated with that, and then answer the questions and submit those to Blackboard. So that should be the process that we'll go through. So the first step was to review here the background on this. And what the tutorial is doing is showing you a scenario with this home furnishings, and they're looking for, they had their quote unquote market profile for lower to middle class working families. And so they have, income set up and things like that. So they have a couple stores though, and they're trying to figure out what's going on with some of the stores. Like, why is one store maybe doing really well and the other one not doing so well? And this is a really common, I think, question that franchise locations probably have to experience. Why is one Starbucks doing really well and another one not so well? Or, there's a ton of different franchise stores out there, and again, it's a common thing, but it's all about what's happening in those market areas. So this lab is designed to take you through that, to understand how you can use market areas and market potential indices. And so as we come down through this document, what you'll want to do is first click on this link, and that will take you through all of the steps and how to follow the prompts, and that will take you through everything that you'll need to do. So again, this should take you maybe about an hour. It's relatively simple. There's not a lot of complexities in here, and it is kind of a fun one to look at and explore and think about. So if anyone has any questions on this, please let me know, and I'll be happy to help you out. Or if you would like for me to create a step-by-step process of how this looks in a recorded session, if that would help you, let me know. So otherwise, I hope you have a good rest of the week, and we'll see you online here again soon. Thank you.